Hi, I'm Madison Lindberg, and I'm here at Wagstaff Incorporated with Casey Robinson, who is a mechanical engineer here, and he's going to be leading our tour for today.
Thank you, Madison, for that great introduction, and welcome to Wagstaff. We're excited to have you here as part of our tour. So we've got a lot to cover, so let's just jump right in, shall we? So Wagstaff is a 74-year-old family-owned company. We're recognized leaders in the design, development, supply, and service of aluminum casting equipment to aluminum producers in over 50 countries around the world. We also have a division of the company that specializes in select power generation industries, but for today's tour, we're going to focus mostly on the aluminum side, okay? So one of the great things about working at Wagstaff is most of what we do is done right here in Spokane. So at this campus, we have a wide range of employment opportunities. Those range from sales representatives, engineers, designers, welders, machinists, and quality assurance technicians, just to name a few. So before we get started in the tour, I'd like to use a couple of illustrations to help describe our process and our equipment. So our equipment is installed in what's called the cast house, very similar to Kaiser Trentwood, just down the street from us. So the whole process begins when our dedicated sales force makes a sale with a customer around the world. Once that is done, the sales force meets with the engineering team to kick off the project into engineering. Let me show you some of the things that might be on the project, okay? So our equipment is designed to receive molten aluminum. So our customers will dig a large pit in the ground. At the bottom of that pit, they'll install a hydraulic cylinder that's manufactured by Wagstaff. That cylinder will raise a starting head base until it's in very close proximity to the mold table, which has lots of individual molds in it. Once everything is ready, the customer will introduce molten aluminum into the top of the table, and as it begins to solidify, the cylinder will descend at a controlled rate. So as aluminum enters the top of the table, liquid, it exits the bottom of the table in a solid shape. In this case, it's a billet, and it's cylindrical in shape. The process is similar for what's called ingot casting. Ingots are rectangular in shape. The main difference is that in ingot casting, we have a trough above the table on the molds that has a device that both monitors and controls the flow of aluminum to each mold separately. So when the process is complete, the flow of metal is stopped, the tables are tilted out of the way, and the product is removed from the pit. When that's done, the product will be sold to other customers to produce into their final product. So things like beverage cans, aluminum bike frames, foil, those kind of things are what aluminum is used for. So I would encourage our viewers right now to pause the video to watch a couple of short animations that describe the process even better to help you understand the aluminum casting process. So with that, Madison, why don't we move on to the next stop in our tour and show you what's next in the process?
Great, I'm excited to see it. Let's go. Wow, there's a lot of activity going on in here. Where are we?
You're right, Madison, there is a lot of activity. So this room represents a small portion of our production engineering team. So once the sale has been made, sales meets with engineering to hand off the project. This team then goes to work creating what we call approval drawings. We design those so the customer can look at what we've designed to make sure we've done everything correctly. And often, our engineers will actually travel to the customer site to review the project with them to get everything approved. And then once that's done, the team goes to work creating full 3D models of all of the equipment for the bills of materials and the drawings. So in our processes, we try to use the latest in technology. So let me describe some of what's going on in the room here today. So right here behind us, we have a 3D printer. 3D printers have been very instrumental in helping us do rapid prototype development and in creating fixtures for the manufacturing process. That's what's being printed right now. If you look right in front of us, we have Aaron and Amy. They're looking over a design that's a new concept for us. Almost that entire assembly was 3D printed. Over here to our left, we have Paul and Wei, who are working with a set of augmented reality glasses. We recently had a job in China that we commissioned. We had an engineer in Spokane that was online with our technician in China. We could see everything that they were doing and send them instructions over the goggles to walk them step by step through the process. Over here to our right, we have Jeff and Micah who are looking at a complex manifold design. That manifold has a lot of repetitive welding in it, and so we're actually looking at robotics to do the welding. And finally, we have John and Jean who are working in SolidWorks to do 3D modeling. Jean is finishing up the design of an ingot mold. We're going to see more of that later on in the tour.
Do a lot of your engineering professionals come from this region?
Yes, in fact, the vast majority of our staff come from right here in the area.
Is there a special type of engineering you use here at Wagstaff?
Well, the vast majority of our engineers are mechanical, but we also have electrical, metallurgical, and computer science engineers.
So what else goes on in here, and where do we go from here?
Well, once the team is totally done with their work, they're going to release their projects, the bills of materials, and the drawings down to manufacturing.
What do you mean by manufacturing?
Let's head to the shop floor and I'll show you.
This is a busy place. What's going on in here?
You're right, it is a very busy place, Madison. So right now, we're right in the middle of a large group of CNC machines. In fact, within short distance of us, there are over 16 CNC machines of different types used in our manufacturing processes. These machines closest to us are used mostly for the manufacturing of ingot molds, like we saw in engineering, and like we see right here on the floor. This machine behind us is our newest machine, and it's capable of 5-axis machining. What that means is it has not only X, Y, and Z axes, it has a C axis, which allows the head to rotate, and an A axis, which allows it to tilt at an angle. You can see it has very large viewing windows for seeing the product, but it also has a control panel where the operator can see inside the machine and make adjustments as necessary.
Is there any special type of training that's required to operate these machines?
Yes, there is. Typically, it involves getting an associate's degree from one of our local programs, and then once they're on the job, there's continued training for some of the more sophisticated aspects of machining. So now that we've seen this area, let's head to another building and we're going to see some welding and fabrication of some very large assemblies.
So, what's going on here?
So right now, Madison, we're in an area of the plant that does both welding and machining of large assemblies. So this process begins down the aisle where raw material enters the building. We cut it and burn it into its final size and shape and move it down the line to the fabricators to be welded.
So what's the difference between fabricating and welding?
Good question. So fabrication is actually the act of putting the pieces together, kind of like a 3D jigsaw puzzle. And then welding is actually a high heat process that actually melts the metal and then binds it together once it cools. Like our machinists, welders often get an associate's degree from one of our local programs and then continued on-the-job training. In fact, Madison, as a nation, we're facing a shortage of people that want to work in the skilled trades. So we want those that think maybe a 4-year college degree isn't for them to consider these great alternatives.
So what are these big machines that I see?
So these machines are also CNC machines, just much larger than the ones we saw earlier. Behind us is a machine that has a billet system on it, like we talked about earlier. Every billet system that we have has to cross through one of these two machines, so they're very important to our process.
So where do we go from here?
Let's go to the last step of our tour and I'll show you.
Wow, these things look great. What are they?
They do look great, don't they, Madison? Thank you. So right now we're in final assembly. This is where it all comes together. This is where our mechanical and our electrical technicians bring all of the parts together into their final assemblies. In this bay behind us, we see a large amount of billet systems in various stages getting ready to ship to one of our customers in Russia. Directly in front of us, we have what's called a rolling pit cover that's in the process of being assembled. And then over here behind us a little ways is what's called an ingot trough. We talked about that earlier, and it's ready for final inspection. Once everything has been inspected and tested and ready to go, we'll box it up and ship it to our customers. It's going to travel by semi-truck and sometimes by ship overseas, sometimes taking up to 2 months to reach its final destination. And it's thanks to our over 400 employees here at Wagstaff to make it all happen.
Wow, who knew that something so important was happening right here in Spokane?
I know, right? That's why we're so glad you came to see us today.
Thank you. This was a really great tour, Casey. Thank you.
You're so welcome, Madison. I sure hope you enjoyed it, and I sure hope that you and our viewers have learned something new and interesting about Wagstaff. So thank you again, and bye for now.